I apologize, that last video ran out. My free subscription for this video recorder only allows 15-minute videos. Wasn't paying attention to the time. So we got to right here. We know that it's negative on the left side of our first critical point, which is pi over 3. So it's negative values here. Then in between pi over 3 and 5 pi over 3, it's increasing. And then after, to the right of 5 pi over 3, which is our other critical point, it goes back to decreasing. So we know that it's got a minimum here and a maximum there. Those are our relative extrema. So the minimum occurs at pi over 3, and then the maximum occurs at 5 pi over 3. And in this case, they're asking where they occur. If they're asking what are the values of the extrema, then you would need the y values as well. But here it's just, hey, find where the relative extrema occur. Again, if they want the value of the relative extrema, then we're going to plug pi over 3 and 5 pi over 3 back into your original function to find what the y values are. Those would be the values of those critical points. Okay, so let's take a look at another example. Go ahead and find the derivative, set it equal to 0, and then identify any local extrema using the first derivative test of this function. Pause the video, try this on your own, and then come back and see how you did. So once we set it equal to 0, find the derivative, set it equal to 0, you should identify your critical points as positive, negative 2, and 0. Because remember, critical points occur also where the slope is undefined. So that means you have to set both the top, which is 4x, and your denominator, which is 3 times the cube root of x squared minus 4 equal to 0, and that's where we get those 3 values. So then if you haven't already, set that up on a number line with your critical points being at negative 2, 0, and 2, and then find values to the left and to the right of each one of those critical points, plug that into the derivative, and determine if it's a positive slope or a negative slope. When I identified points to the left and to the right, I chose negative 3, negative 1, 1, and 3. And then I'm plugging those into your slope, right? And when I plug negative 3 into the slope, you notice that all I care about is positive or negative. So on the numerator right here, this gives me a negative answer. That's why I have a negative up there. And then in your denominator, that gives me a positive answer. So a negative over positive gives you a negative. So on the left side, between negative infinity and negative 2, you know that it's all those slopes are going to be negative. And then you plug in negative 1, and you get a negative over a negative, which gives you a positive. So between negative 2 and 0, that gives you a positive answer, so your slopes are going to be positive. And then we look at when we plug 1 in there, you get a positive over negative, right? Because 1 minus 4, that is a negative answer. And you can take the cube root of a negative, not the square root or any even root, but an odd root you can find, right? And that gives you a negative. So between 0 and 2, that's negative. And then do the same thing for the last one. You get a positive over positive, which is a positive. So then from 2 to infinity, it's always increasing, right? So our local extrema occur at f of negative 2, right? So when at x equals negative 2, that would be a minimum because it goes from decreasing to increasing. At x equals negative 2, and also at positive 2, because it also goes from decreasing to increasing, so that would be your minimum. And then your maximum would occur at 0. Right? So we identified our extrema at negative 2 and 2, that's our minimum, and at 0, that is your maximum. Let's do one more together. Try this one. Use the first derivative test. Find the derivative, use the first derivative test, and then pause the video, try it, come back. Okay, so first of all, there's a couple of different ways you could go about doing this. What I did is I went ahead and just rewrote this x to the fourth plus 1 over x squared. I took x to the fourth over x squared plus 1 over x squared, and that simplified down to this, right? Then I can find the derivative of just x squared plus 1 over x squared. Again, it's the same thing. You could do the quotient rule and get the same thing, okay? So don't undo anything. If you ended up doing the quotient rule, we will arrive at the same answers. So when I find the derivative, you get 2x minus 2 over x to the third. This is the derivative function right here. I set that equal to 0, and then use a little bit of algebra. I take the negative 2 over x to the third to the other side, and I see, hey, first of all, I cannot have 0 in as x because it's in the denominator. So that's my first critical point, is 0. So then when I cross multiply here, this could be over 1. So that's where this came from. And I set that equal to 2, so cross multiply. Divide out the 2's, you get x to the fourth is equal to 1. So x can be positive or negative 1. That is our other 2 critical points. So we have 3 critical points that we're going to put on our number line. Test values to the left and to the right. So I decided to test values of negative 2, negative 1/2, and 2 to determine if the slopes are increasing or decreasing. So we plug those into our derivative, and this is our derivative right here. That's what I'm using. So I'm plugging negative 2 in there, and when I plug negative 2 in there, you get negative 4 plus 1/4. So that gives me a negative answer. And that's all I care about, positive or negative. And then over here, you get a negative 1 minus a negative 16, because 2 divided by 1/8 is 16. And that gives us a positive answer because of the minus and negative. 16 is larger than negative 1. So that gives me a positive answer. So up here, from negative infinity up to negative 1, it's decreasing. From negative 1 to 0, it's increasing. Now, from 0 to 1, value in between is 1/2. Plug that in there, you get 1 minus 16. So that's decreasing. And then you would get 4 minus 1/4, and that's a positive. So it goes back to increasing, right? So then it goes from decreasing between 0 and 1, and then increasing from 1 to infinity. So at negative 1, it goes decreasing to increasing. That's where a minimum point is. It's kind of made a smiley face. Here's a frowny face, maximum. When it goes increasing to decreasing, minimum, decreasing to increasing. So you identify those points. There are 2 minimums, right? So minimum at x equals negative 1 and 1. And then a maximum at 0. And that would be our extrema. Okay, that's all that I have for using the first derivative test. I hope you understand it. If not, ask me in class.